Thank you very much for the opportunity also to speak here about the project. You can see on the screen that a very beautiful structure, and it has all ornamental finishes, and the most of it, like you have the crown, the two trellis are there, and the thing is that it's kind of a earring. So that is also all the facade is done in structural steel, the ornamental, and the project is basically called as NMAC, so NMSCC. It is Nita Ambani Cultural Centre, and the project has been launched on 31st of March, and it has been getting the popularity amongst the Indian also Indian crowds and also abroad also. So basically, yeah. So the project basically is is the dream of the founder person of the Reliance Foundation, that is Nita Ambani, and it is basically meant for the artist. So we can call it as a hub for the all artists. So it is dedicated for multidisciplinary arts, and it is to promote the talent what India has. So I'm going to basically talk about the grand theatre here. So the dimension of that theatre is about 60 meter by 37 meter, and it can accommodate 2,000 audience. And there is a hidden orchestra pit which can accommodate 80 musicians at a time. So there is a small two auditoriums also, which is 250 seat and 125 seat. And of course, the art house has about 16,000 of square feet, so, and it is 4-story. So I'm going to basically talk about the theatre one. Yeah, so this cultural center is basically the part of the iconic structure, which is the JIO World Centre. You can see the behind, that is the convention center. So this box is basically this the theatre, the grand theatre, and the dimension of it like 60 meter this way, and width is 37 meter. We have used almost about 2,000 plus tons of the structural steel in making of this theatre. So I will briefly describe the speciality of this the structure. So coming to the shape of this theatre, it was derived from the flowers, orchid. So the image you can see in the middle over here. So that forms the shape of the box. And what you see on the right side here is that the architectural plan of the the seating area. So yeah, so this is the view. So stage is on the left side over here. And what you see on the first 4 rows are actually the orchestra pit. So there is a piston lift below these 4 seats, which which allows the movement of the seats, and the seats go down and the orchestra pit comes in. So similarly, there is another lift for the media pit. So you see an aisle here, over horizontal aisle. So that horizontal aisle has this middle rows is actually a piston lift. So that also, the seats go down and the orchestra pit comes up. So I'll show you in detail. So this is the structural plan for this box. So the dimension of this is 60 meter this way and 37 meter in width. So this box has basically a 600 mm thick shear wall all around. So stage is here on this side. Yeah, so basically, yeah. So this area is a stage. This one from here to here. And we have this, what do you see, a grid pattern over here. This is basically the folding stage, which is demountable. So for any performance which requires, the act or anything which requires the entry of any actor or any, monument or something. So this stage can be removed and then reinstalled immediately. So all the connections are pin connections for this stage part. Then you see on the right side of the stage, so this area is basically the extension of the stage. So these are all telescopic tubes. So those telescopic tubes normally goes out by about 1.5 meter or so, as you know, as per the demand of the performance. And ahead to that, that this cutout is basically the orchestra pit. So there are lifts which comes down and then goes this way. So whenever there is an orchestra, the 80 people, 80 musicians can fit in that orchestra. So this entire assembly is at the ground floor and also at the basement level. So you see on the right side here, so right side when you go up, so these are all horizontal girders, RCC girders, from which we have taken the steel columns up to support the balconies. And that area is entirely hollow. So there is no, that has been prepared as a plenum from where the cooled air goes in. So I'll show you the longitudinal section across the length and also through the stage of this theater. Yeah, so look at the bottom. So we have a stage over here. So this is the folding area where the stage can be demounted. And then that is the extension one. So we have there is a pit over here at the lower basement, basement 2, where the, the lift is accommodated. Similarly for the media pit there on the right side, so the lift is accommodated over there. So whenever there is a show which requires more capacity, the lift goes up and the chairs are being put like. So you can see the hollow space there below the seats over here. So this is all the air condition from where the ventilation is provided to the audience below the seats. So similar plenums are there at the level 1 and level 2. So you can see there are steel columns which are floated from the girder at ground floor, from this one. And the large cantilevers of about 4.5 meter are provided. Basically the RCC wall is constructed first, that was on the critical path, and we erected the truss at the top first. So this 40-meter long truss you see, so that is basically the cross section of the truss. So there are 4 such truss, placed like this, and then the wall was there, the trusses were there, and then the internal steel structure work was carried out. So there are catwalks also. So and these are the VIP boxes. Like these levels are all VIP boxes. This is the cross section of the theater from the stage area. So at the top you see the truss which is erected first. And then these are the boxes on the sides, both sides. So there is a 4-stage grid is also there, which is used to lower down the objects, and the any performance related items are there which can be hang and then lower down for the entry effect. So as I said, the walls are there which are designed for the lateral load, and the steel structure, internal steel structure is designed for the gravity loads only. And all the connections, the insert plates and all were planned in advance so that you can provide the insert plates according to the MEP requirement. And yes, so this is basically the detailed view of that orchestra pit which I said. So there are cases like 4 row up with the audience. Then if you require 2 rows only and the stage can be extended. Another third case where the stage is exactly taken a full shape and gone up to the first aisle. The similar view is of orchestra pit where the orchestra pit is being used partially. On the right side you see the one lift is there up. On the middle photo you see 2 lifts, and the third photo on the left side is completely seats are up. So you get more capacity. So all mechanism is be coordinated with the theater consultant. This is the stage extension. So right side you see on the top side is the plan where uh, the telescopic tubes are springing out from the hidden beam inside. It's not working. I have to point it like this only for me. Yeah. So this is the view of the plan view of the demountable stage, which I said. So there are 4 columns inside it, and all the Indian steel sections, and then there are tubes also. So all bolted connections which can be removed and placed immediately for the performance needed. Next. This is typical detail connection for those demountable assemblies, wherein we have used the columns as tube sections and then beams are ISMB 300. Next. So the walls were cast first, to allow for the speedy construction of the adjoining structure. So the shape of this, the curved wall, on the back side, so that was stable enough. So we, please go back one side. Yeah, it's working. Yeah, so this shape was stable enough, the curved one, but the other 2 vertical and horizontal walls were not stable for that height of 40 meter. So we introduced the structural steel to avoid lateral buckling of those walls. So in elevation you see these trusses, and all the structural steel members, you can see the steps and all. So these trusses were planned like that they will not hinder with any of the construction activities and insets and all. So almost about 250 plus cutouts were there for MEP, and about 500 plus insert plates were there used for the structural steel, which is going to be placed inside later. So the tower crane was placed inside the theater, like inside the stage area. And then the blue color you see, those were the temporary steel beams which were connecting to the RCC girders from which the steel columns are springing up. So then the trusses were raised from these steel beams, and then the truss was erected. So truss were erected in parts. So this is the view after erecting the truss. So later on we erected the the balcony cantilever truss, the cantilever, these were like customized plate sections and all. So they were pinned at the shear wall area, and then cantilevering out from the steel column which are floating. So at the 3rd floor you see the curved wall is going out, so that portion of the wall was floated. Otherwise almost 70% of the walls were taken from the foundation. This is another photo. The top area is used for parking, so that was done in structural steel. So this is view of the complete box. This was during the execution of the installation of the truss 1. So it was brought in parts and then erected. The walls were done first, and you can see on the behind the CEC area work was in full swing. So this is after erection of the truss, and the top roof is being laid. So this is the view during construction from inside. So as I said, the cantilever is for the 2 levels of balconies, and you see the boxes on the right side. Those were in making. This is the view from the stage during the construction. So all erections are done. The boxes are there on the right side and the left side. So 2 levels of the balconies. The green one you see, those are basically aisles on the top side, and that is the 4th floor level. So the trusses, the bottom of the truss is also seen. This is bare structure, and the next photo will be of the completed section. So this is the same view from the same photographs from the stage, and this is the area where the stage is completely extended till the first aisle. So boxes on the both side. The false ceiling is there with the Swarovski crystals. So there is a lot of structural steel work behind there to support the roof, the false ceiling. So this is the view exactly from the opposite side. So you see a stage, you see there are some parts of which are not visible over here, but the structure is there, but it's not completely visible because of the night. So you see a line over here. So these lines are basically, this is that shape of that telescopic one, and the next to that is basically the extended part of the lift which goes up. So this is without any orchestra pit now. All things are up, and the stage area which is demountable. There are also grids you can see on the floor. This is another view from the side. So beyond the boundary of the theater, so that curved wall is there. So beyond the curved wall, here also we have used the structural steel as a hanger. So we have used about 85 mm, 75 mm thick diameter rod, which is high tensile, about 1700 MPa yield stress. And we have used it for the capacity of 220 metric ton. And we have kept a clear gap between the rod and the concrete so that it remains purely in tension. Right side you see the connection details over there at the top and at the bottom. So after erection it looks like this. So the bottom level is this, from where it is being hung. That is the PT beam that is there at the top, from where it is getting hung. So you see a staircase also there, which is the almost 2.8 meter, almost 3 meter cantilever from the wall. So that wall was being cast first. So all the insets and for the staircase and all those were laid first. And then we erected the folded plate, about 20 mm thick plate is there for that staircase. So this is the view during the construction. Another view. So it's connected, basically supported from the wall. So this is the view after completion. You see the rods like 1, 2, 3, and 4, and the staircase is there on the inner side of it. This is the view from the lobby. So basically for this structure, we have used structural steel in construction as well as in the artifacts. So almost 50 to 60% of the artifacts we have used structural steel, and I mean that's it. So this is it from my side.